Okay, in this new design that I'm coming up with for this wind turbine, what we have is a tail mounted on the back like this, weighted with a 20-degree angle shaft here with bearings top and bottom. And the concept is that the head is off center here. If you look at the top head here, here's the wind turbine motor here. So here's the production of power. And of course you have their two bearings here to hold the yawl here to keep everything, the yoke, properly in place. And then of course your wires coming down the base with a slip ring washer there and reading into the turbine motor. Anyway, so what happens is that this is offset from your shaft. So you have your tower right here coming up, and this is offset. So the motor sits on this side, and so when the wind blows, it pushes against this at a certain level, and that balances with the weight of the tail. You can see the tail here is at an angle, so the tail desires to stay straight and will always stay in the wind. And so as the wind picks up, what happens is that the blades, when they're pushed with the air, they push hard, and then what happens is they come back like this, pulling and the tail staying straight. When the wind picks up, what happens is the tail comes up in the air like that. And when the wind drops so that it's actually a safe level, the tail then pulls the turbine back straight into the wind. It's a very simple design, a very old concept. It's been around for a long time. And I think it's a simple way to fix a turbine from getting overspun by too much wind. Again, it can be regulated by how much weight is on the back of the tail, and the length of the tail can regulate at what wind speed the turbine turns out of the wind. This is to keep this from getting too hot and overspun in high winds.